Okay, so this is my video for uh, standard 5.2, which gives us an arbitrary wave function for a particle in an infinite box, and asks us to determine the time evolution of this wave function, and then asks us to determine the expectation value for its energy. So first, what we need to do to find the time evolution is rewrite our state vector in the energy basis instead of the position basis. So what we need to do is find out how much of our wave function is quote unquote in the direction of an arbitrary energy eigenstate. And since we have all the energy eigenstates, all infinitely many of the energy eigenstates in a general form depending on n, what we want to do is find how much the direction, how much of the wave function is quote unquote in the direction of the nth energy eigenstate, and then take the sum over all n, and that will give us our initial state vector in the energy eigenbasis. So to do that, we take the inner product, and since we are dealing with a continuous variable here with the position, since we're in the position basis, we need to take an integral over the length of the box. So that's what we do. We multiply our two wave functions together and take the integral. And what we get out is just a number that it's a pretty ugly looking expression that we could probably simplify a little bit more, but for the sake of this discussion, we know all we really care about is that it's a number that depends on n. So for the rest of this problem, I just call it psi n. So therefore, since given the nth eigenstate, the coefficient, given the nth eigenstate are the coefficient in front of that eigenstate for our state vector written in the energy eigenbasis will be psi sub n. So therefore, our initial state vector written in the energy eigenbasis is the sum over n of all the energy eigenvectors multiplied by their respective psi n's. And again, that is this quantity here, which we got from integrating. So therefore, since the Hamiltonian here is time independent, we know that our time evolved state is going to be this sum with our decaying exponential. So now what it asks us to do is calculate the expectation value for energy. So we know that the expectation value for the energy is going to be the sum of all the possible energies times the probability of measuring that energy, which is what we just found. So, sorry, that's not what we just found. We found our time evolved state. But to find the probability of measuring each energy, we need to take the modulus squared of our nth energy eigenstate with our time evolved state, and then that is right here. And then you can see that since we already have our time evolved state written in the energy eigenbasis, the probability of measuring that state in one of the energy eigenstates will just be the coefficient that we found from integrating earlier, psi n squared. So then our expectation value will be the sum of the nth energy multiplied by psi n squared summed over